Okay, this is lesson 6 of hands-on equations. You need the same materials, blue ponds, red cubes, and laminated scale. Our learning target for today is I can solve multi-step algebraic equations and use the distributive property of multiplication over addition to form equivalent statements and expressions when solving algebraic equations with one variable. So the new part that you are learning today is this piece right here. Is the distributive property of multiplication over addition to form equivalent statements or expressions. A statement is just another word for saying a number sentence, just what we've been doing all the time. So let's just take a look at what is distributive property of multiplication over addition. So we know when we're talking about multiplication, for instance, if we're saying 5 times 12 equals 60, and we know this to be true, we can express it as 5 times 12, or we could break apart the 12 and break it into a 10 and 2 ones, like it is over here, and say that 5 times 10 is 50, and 5 times 2 is 10, and when we add 50 and 10 together, we get 60. So that's what is shown down here. Each 12 is 10 plus 2. We multiply the 10s and 1 separately and then add. 5 times 12 equals 5 times 10 plus 5 times 2, which equals 50 plus 10, which equals 60. Another example would be if we're talking about the number 3 times 27. And this is a good thing to do if you need to multiply this in your head, is break apart this larger 2-digit number and think to yourself, well, 3 times 20 is 60, and I know that 3 times 7 is 21, and then in my head all I have to add is the 60 plus 21, which equals 81. Down here are 2 more examples, but now it's written a little differently. Notice how they wrote it out here. Instead of pictures, it's now an equation. So it's saying 6 times 18 equals, or is the same as saying 6 times, parentheses, 10 plus 8. It's the same process. You would then say 6 times 10 is 60, and 6 times 8, which is 48. This is the distributive property over addition. Because we have addition in the parentheses here, we're distributing our multiplication over this addition in the parentheses. And 60 plus 48 is 108. Here's another example over here. 7 times 32 equals 7 times 30 plus 2. Distribute the 7 over the parentheses. 7 times 30 is 210. 7 times 2 is 14, and you can add 210 plus 14 equals 224. The distributive property over addition is really easy, or really helpful when you're solving mental math problems, because it does help you break down these larger numbers to multiply into smaller numbers that are easily multiplied in your head. Because I can easily multiply 7 times 3, know it's 21, and add the 0 to get 210. Alright, let's look at another example. This is just using variables. No numbers in this one. Saying the distributive property states that multiplying a sum by a number gives the same result as multiplying each addend, and addend is the numbers that we add together, by the number and then adding the products together. So if we had the equation A, remember this is an understood multiplication right here, A times B plus C equals, or is the same as saying A times B plus A times C. So let's apply this to hands-on equation. What does that mean for us today? Here's our first equation. We have 2 times x plus 3 equals x plus 8. Well, how is this going to be built on our scale then? How are we going to show this using our manipulatives? Well, there's a couple of ways that you can do this. You can think what this is really saying is x plus 3 and whatever that sum is times 2. So it's really like saying x plus 3 plus x plus 3. Two of them. Because we know that repeated addition is the same as multiplication. So we can think of it that way. And then on our scale, you could x plus 3 and x plus 3. And then if you're like me and you like things to be neat and organized in their place where they're supposed to be, you would put all your x's together and all your number cubes together. So that's one way you can think about it. Another way you can think about it is, erase this, go ahead, and since we know that the distributive property of multiplication over addition tells us that 2 times x plus 3 is the same as, I can distribute my 2. 2x is 2 times x plus 2 times 3, which is 6. And then I can put my pieces on my scale. And really, isn't that the same thing that we had the other time, except we had 2 x's and then 3 and 3, which equals 6. So it doesn't really matter which way you do it. Just pick a way and make sure you're comfortable with that way. So then we can finish it and go ahead, solve for x. Okay, remember to pause if you haven't solved yet. You should get, when solving this, that x equals, whoops, that was a z, x equals 2, and your check when you plug 2 in, 2 plus 2 is 4, plus 6 is 10, and 2 plus 8 is 10, so you get 10 equals 10. Yes, that is correct. Okay, so now I'm going to put another one up here, and I want you to choose however way you're going to show it on the board and solve for x. So now we have 2x plus 1 equals 18. So take a moment and build it on your scale. Okay, does your scale look like mine? If you have this, 2x plus 1 and 2x plus 1, and then 18 on this side, isn't that the same thing as 4x plus 2? Absolutely. It doesn't matter how you distributed this number. It's the same value when you put it on the scale. So go ahead and solve for x. Remember to pause. I'm going to put the answer up. You should get x equals 4. And when you check it, you should get 18 equals 18. Okay, let's try another one. This one's a little bit longer. This one is 2 times x plus 4 plus x equals x plus 16. Go ahead, take a moment, create that on your scale. Okay, when I solve this, I go ahead and solve by distributing the number over the parentheses. So what I did was I got 2x plus 4 plus x. Actually, I didn't get plus 4. That would have been plus 8. Because 2 times 4 is 8. Okay. Then I can combine my like values together, my variables. 2x plus x is the same as 3x plus 8. So that's why mine might be in a little bit of a different order than yours, but as long as you have 3 x's and the value of 8 equals x plus 16. And go ahead, solve for x and check it. I'm going to post the answer, so pause. If you need more time, you should get x equals 4 and 20 equals 20. So that is lesson 6. And today you learned that you can use distributive property of multiplication over addition to form equations that are equivalent. So 3x plus 8 is actually equivalent to this first equation that I gave you. You can say that you can write them 2 times x plus 4 plus x equals 3x plus 8. Those are equivalent statements and expressions. Okay, go ahead and complete the lesson 6 worksheet.